All right, so we got 5 problems. We have number 63 and then 65 through 68. Those are the only ones that we had left on here. So let's do this quickly. On number 63, it said fill in the blanks below to match each corresponding part of the congruent triangles. So we have 2 congruent triangles there. We had to match up all the corresponding parts. So they gave us something to match it up to. For the angles, it's a little bit easier because we can just look at the angle and say, all right, here's the angle that's a right angle. P is the right angle over here. So angle A is congruent to angle P. Then we have angle B. All right, it has the 2 marks on it. So go over to the angle with the 2 marks. That's angle Q. Angle C has 1 mark on it. So angle R goes with that one. Angle R. Now, the sides are also marked this time. So unlike the last one, we already have all the sides marked as well. So this one's not too bad either. So AB has 3 marks on it. Go to the 3 mark side. That would be PQ. Now, if you did reverse the order of that and said like QP, that would also be fine. So then we had BC. BC was the side that had 2 on it. So QR would be the side it matches up to. Again, it's a segment, so you need to make sure you put the segment notation over top. And then AC had 1 line on it, so PR went with that. Oops. PR. Again, if we had reversed it, that would have also been fine, so RP also works. Any questions on that one? Just naming them. All right, then on 65. Whoa, why did it go all the way to the end? That was weird. Try that again. All right, on 65. Triangle ABC is similar to triangle DEF. Again, this little squiggly line right here, this little line, that's telling us that these 2 triangles are similar. So fill in the blanks below. We have ABC corresponds to, and again, what angle does it correspond to? Well, ABC corresponds to DEF. And we should always use more than just the diagrams themselves to tell us this. The actual statement at the top tells us which order they correspond in. So ABC is right in order there. DEF, same order. Then we have BCA. So looking at that statement at the top, BCA, going in the same order. EFD. EFD. And then finally, CBA, again, looking at the statement at the top, CAB, FDE would be the same order. So again, just using the same order as the statements are in on the top helps us put them in order. They don't even have to give you the diagrams. All right, number 66. Again, that statement at the top tells us how they're matching up. Find measure of the angles listed below. So on this one, we have measure of angle KLM. Well, again, the vertex is at L. Looking at that original statement at the top, that's in the same position as Y. So what's the angle measure at Y? It's 110. Then going on to the next one, we have LMK. So M is our vertex. Right? We're looking at the statement. M matches up with Z. So 25 is going to be our angle measure. And finally, looking at the last one, K is the middle value. So that's our vertex that we're looking at. And K from the statement matches up with X, which is the 45. That's it. All right, 2 more. On 67, this one tells us a similarity statement as to how they match up. It says find the values for X and Y. Well, this time we have to do a little bit more work. So anytime we have similar figures, the sides are going to be proportional. So they should share the same ratio. Now, X and Y are on these 2 sides. So first we have to figure out the other side that they actually gave us a measurement for. We have to take that and match it up with the corresponding measurement on the other side. So on here, we can write a ratio of 6 to 12, which if we want to, we could reduce that to 1/2. So the ratio each time should be 1/2. Now you can do this a couple different ways. If you want to, you can take that ratio and just multiply by it. 1/2 is easy to multiply by. So we could just say, all right, 13 times 1/2 is 6.5. 5 times 1/2 is 2.5. Now you're not always going to get an easy number to multiply by. So the other way that you can do this is actually setting up ratios. So let me do it that way just so that we can see both. So let's say we're solving for x first. Well, x matches up with the 5. So if I was writing a proportion, that's where two ratios are set equal. I have 1/2 is equal to x over 5. And then you cross multiply and solve. 1 times 5 is equal to 2 times x. So 5 is equal to 2x. Divide by 2, and you get 2.5 equals x. And I know that seems a lot longer than what I just did. No, that's a lot longer than what I just did the first time, but that's going to work every single time. So setting up two ratios that are equal, cross multiplying and solving. The other method that I used the first time, you had to set up a ratio with the new figure to the old figure, and then multiply by that ratio. Either way works, you get the same answers. All right, so if we do the other one, we got for y matches up with the 13. So doesn't matter if you use the 1/2 like I did on the last one. If you use the original amounts without reducing it, it would still work as well. So I'm gonna go ahead and do this one with the original values of 6 and 12 this time. We have y over 13, cross multiply and solve. So we have 12 times y, 6 times 13. That's going to be 78, I believe. And then divide by 12. That gonna be 6. I don't know if I did that right in my head. Hold on. Let me check my math because I don't think that's right. 6 times 13, 78. 78 divided by 12, 6.5. Yeah, I was off by a little bit. And if you remember what I had at the beginning, which I kind of forgot about, 6.5, I believe, was the answer I got because that was half of the 13. All right. Last one on 68. Are the triangles below triangle ABC and triangle XYZ similar? If so, what is the similarity ratio between the two? So in order to know if they are similar, all the sides have to have the same ratio. So looking at the sides, matching them up. If I match up the 4, that'd go with the 5 in the other figure. If I matched up the 6 on the first figure with the 7.5 on the other figure, and then matched up the 8 with the 10, all three of these have to be equal. Well, in order to tell if they're equal, the easiest thing to do is just divide them. If I take 4 and divide by 5, that gives me 0.8. If I take 6 and divide it by 7.5, we get 0.8. 8 divided by 10 is also 0.8. So they are all equal. And since they're all equal, they have the same ratio, which means they're proportional, and the triangles must be similar. So the answer here is going to be yes, they are similar. And then we wanted the similarity ratio. Well, simplified form here would be the one that we did first, that 4 over 5. So we can say yes. And then we can say the ratio is 4 over 5. Now, it didn't specify as to which one it wanted first. So you could have said it as 4/5 or 5/4. Both would have been acceptable. And that's it. That's the whole review. Any questions?
I finished the last teacher review. But I said it was exactly in the clock. I exactly in the clock. So I think at 12:59 or 11:00.
I mean, if it was that close, I can leave it. Any other questions?